Hello, everyone. Welcome back to our function topic. We are gonna cover the concept of what a functional value. Now, in the last session, we talked about relation of function. All right. Now they are very similar to one another. How they are very similar to one another? How the functional function is different from the relation. Now we are going to talk about or turn our attention specifically the types of the function. Today's session is the types of the function. What type of the functions are there? And to identify the function, okay, types of the function. I have mentioned before, function are basically what you are going to use throughout the algebra, throughout the physics, throughout the geometry, throughout the calculus. In this session, I want to show you a types of the function. At the end of this session, you should have able to identify the types of the function. Now let's discuss certain revisions. Now types, the types in the functions, there are two types. One is one and another is many one. One is normally called the injective and many to one also called the surjective function, and one function, okay, onto function and into, and for the many to one also one onto and into function. Now then just revision for certain. All right. uh, Domain, codomain, and range. Now, this is a function defined from the function f, defined from the uh, x square, all right, defined by x square. If you input something, you get the squaring, okay? So like 1 square is 1, 2 square is 4, 3 square is 9, but 16 has no pre-image, no problem. So the set A is called the function domain, okay? Now normally the function is written as f from set A to set B, from set A to set B. So set is called the domain. This is domain, and set B is the codomain. Codomain, all right. Then this is codomain. Set B is codomain, and the range set of image 1, 3, and 9 are the image of 1, 2, and 3 respectively. 1, 4, and 9 are the image of 1, 2, and 3 respectively. The set is the range. All right. Now totally the set B is the codomain. Okay. Sometimes range is a subset of. Okay. It is the subset. Okay. Range is the subset of codomain. This is range. Okay, range is inside the codomain. This is the subset. This is the subset of codomain, sometimes equal also. Okay, in some cases there are the equal domain and range and codomain sometimes equal also. Now let us discuss how to find the functional value. Okay, the suppose the function is given that f of x equal to x plus 1. This is the machine. If we draw the diagram which has already mentioned in our previous class, suppose this is the machine, all right, this is the machine. The process is 2x plus 3. If you write here 1, okay, if you write here 1, then 2 into 1, the processing is it function inside 2 into 1 plus 3, you get 5. All right, you get the 5. Okay, now the function value is uh, calculated by this way, like this. Okay, if you input is normally denoted by x is input, then functional value of 1 is f of 1 equal to 2 into 1. The functional value process is 2 into 1 plus 3 equal to 5. Okay, if you show in the arrow diagram, it looks like this, and we can arrange in the ordered pair form also. Function f equal to, in the set of ordered pair form, first ordered pair 1 is input, output is 5, output is 5, all right. Then second input is 2, then its functional value is 7. It is 2 comma 7 ordered pair form, and in the arrow diagram 2 is a pre-image, 4 is the image, and the image of 4 or functional value of 4 is 9 by calculating, and we can show in the arrow diagram also it is the 3 comma 9. All right, it is 3 comma 9. okay, in the arrow diagram from 3 to 9. And if we input here, if you put 4 as an input, okay, in the machine, mathematical machine, processing like this, 2 into 4 plus 3, 2 into 4 plus 3, we get the 11. So in ordered pair form, 4 comma 11 and enclosed by the curly bracket, and it is shown in our arrow diagram also, that is the 4 comma 11. This is the way to find the functional value. All right, normally x as input and y as output are the functional value. Now the types, first type is one to one, and what type of function are called the one to one, let's discuss about here. Okay, suppose let us consider the function from real number to real number. Real number means all negative, negative, positive. All right, negative number, positive number, integers, okay, whole numbers, natural numbers, including all irrational, rational, these are the real numbers. Okay, the function from 2x, real number to real number, defined by 2x plus 3. Okay, suppose if we input here a 2, okay, right here 1 as an input, okay, 2 into 1 plus 3, you get 5. If you write here 2, okay, 2 2 are 4 plus 3 equal to 7, and 3 and 4, these are the images and function, pre-image, domain, range. All right, now one to one, it is clear that every element in the first set, okay, every element in the domain, every input, okay, separate input, different input, has a different image. Okay, no overlap, different input. One is input, two as input, three as input, four as input. Every input, separate input, has a separate image. One to one correspondent. All right, so it is called the one to one function. Okay, separate image input has a separate output. This is the definition. One to one function if separate element in the domain has a separate image in the codomain. All right, that is called the one to one function. And second, many to one function. Suppose the function is defined as x squared, yeah, f of x equal to x squared. Also, it is from the set R to set R. Okay, real number to real number. 1 square is 1, minus 1 square is 1, 2 square is 4, minus 2 square is 4. Okay, many elements, more than one elements or many elements in the domain has a single result, has a single output. Many, 1 and minus 1, 2, two pre-image, two element in the first set, two element in the domain has a single image, 2 and minus 2, two elements in the domain has a single image. All right, so that type of function are called the many to one function. Many element has a single image, many element has a single image, that is called the many to one function. Now secondly, onto function. Okay, these two are the examples of the onto function. It is clear that 4 or 5 7 9 11, 5 7 9, whatever the many to one and one to one, but we are discussing about onto, it is whether onput or not. Right, to become the onput, 5 7 9 11 are the set of the image, which is the range. But here is codomain is equal to the range. Okay, codomain is equal to the range. In the second example also, codomain is equal to the range. There is no any extra element in the second set without pre-image. Okay, there is no any extra element in the second set without pre-image. Okay, so it is a range is equal to codomain, and here also range is equal to codomain. That type of functions are called the onto function. Now, third is the into function. Okay, now up to this is the onto. Okay, here is onto only, one also, this is many one, but it is onto. This is the function from natural number to real number. Natural number means the counting number. These are 1, 2, 3, 4, 5, and so on. These are the natural number. Real numbers means everything numbers. Okay, rational, irrational, fractional, everything. Negative integers, everything are the real numbers. Okay, 2x plus 1. Here is plus and counting number 1, 2, 3, 4. Only we consider here. You can take the other also, 5, 6, 7, 8, 9, 10 also. But In this example, 4x f of x equal to 2x plus 5, 2x plus 3. If you write here 1 as input, you get 5. Okay. If you input 2, you get the 7, 3, 9, and 5, 4, 11. 4, 11. We get a real number here. These are also the real numbers, and these are the counting numbers from the 1. But you you cannot get negative number by putting in the domain as a by putting in the domain counting number. All right, if you input here, if you insert in the machine counting number, negative number is impossible by this process 2x plus 3. So here is a -1 without pre-image. All right, and in the second example, this is a real number to real number. The function is defined by squaring. Okay, squaring number means the always gives the positive number. All right, squaring means the getting the positive numbers. All right, if you input something, output is always positive. Output is always positive numbers. So in that type of function, it is impossible that to get the result -4, but -4 is also real number. -4 is real number, but you do not get the negative number by squaring, right? And here is a range is the subset of the codomain also. This is a range. This is range, which is the subset of the codomain. This is range, which is the subset of the codomain, which is the subset of the codomain. That type of functions are called the into functions. Now this is a generalization combined. It is clear that one-to-one function column and many-to-one function column. One-to-one means separate input has a separate output. Many-to-one, many input has a single output. All right, and these one-one and many-one and onto row. Onto means range is equal to codomain. Range is equal to codomain. So it is a onto, and into range is proper subset of codomain. Range is proper subset of codomain here. And here is a certain example to identify it is a into or onto. How to find? Remember that into means range is proper subset of codomain, and to become the onto, range is equal to the codomain, right? If you draw the arrow diagram like this, okay, this is the range, this is the codomain, this is the codomain. Now remember this concept, it is applicable for here in this question. Okay, the functional value are given. Functional value of 1 is 5, functional value of 2 is 7, functional value of 3 is 9, and functional value of 4 is 11. 1 is inserted into this machine, so 1 is inserted, 2 is inserted, 3 is inserted, and 4 is inserted. Okay, 1 is inserted, 2 is inserted, input, 3 is input, and 4 is input. These are the domains. These are the domains. All right, and range are, what are the range here? The range are here the result. Functional value means the range. The functional value are here 5, 7, 9, and 11. These are the range. Okay, and what is the codomain? Codomain is totally the set B, because the function is from set A to set B. Set A to set B is the function, so this is the codomain. Okay, 5, 7, 9, 11 is all included by the codomain. Okay, all included by the codomain. 5 is here, 7 is here, 9 is here, and 11 is here. -1 becoming. All right, so this is inside, range is inside, the codomain. Range is inside the codomain. Here is a -1 and 5, 7, these all here. Okay, -7, this is a subset. Its subset means the into. All right, subset means the into function. This is an into function. Similarly, the next example, then how to define, how to identify, is it a 1 1 or not. Okay, 1 1. To become the 1 1, separate element should be have a, it is 1 1, 1 to 1, and on to or not. 1 to 1 means separate image has a separate domain, separate element has a separate output, separate input should be have a separate output, and to become on to, range equal to codomain. Now let's see here. And this is the function defined. Okay, domain are the set A are the domain, set A are the domain, and codomain are the B. And now let's find the functional value. This is input, this is output, input output. Okay, input output, x is always input, this is input, and this is output, this is the output. Now if we input 1, you get 1. If you write 3, functional value of 3 is 2, functional value of 5 is 3, functional value of 7 is 4. All right, now the range is 1 2 3 4. These are the range, 1 2 3 4 range. Then what is the codomain? Codomain is also 1 2 3 4. Okay, it shows that range equal to codomain. All right, range equal to codomain, range equal to codomain, which is B. All right, now it is clear that it is the onto function. Now to become the 1 to 1, -1 has only one image, only one image. 3 has only one image. 5 has also on one image, and exactly one, and 7 has also exactly one. Okay, separate element has a separate output. It means that 1 to 1 function also. Okay, so 1 to 1 and into onto function, 1 to 1 and onto function. It's called the 1 to 1 and onto function. Similarly, the next example, the function is from natural number to natural number defined by 2x plus 1. And is the function f is onto? Again, same property. Onto means the range should be equal to the codomain. Okay, now then find this is a domain. Natural number means 1 2 3 4 and so on. Codomain also from, because the function from natural number to natural number, from to another means the another also the codomain, which is a natural number. Okay, now then find the functional value by this process. 2x plus 1, apply 2x plus 1. Functional value of 1 is 3, functional value of 2 is 5, functional value of 3 is 7, functional value of 4 is 9, functional value of 5 is 11. Similarly, all right, the range are 3 5 7 9 11, 3 5 7 9 11. When the first input is 1, the first result is 3. 2x plus 1 gives always in the ascending order, all right, smaller to bigger number. But in this range, 1 2, then 4 6 8 10 12, all are some natural numbers are missing here. All right, it means that range is a subset of codomain. It is clear that range is a subset of codomain, or range does not equal to codomain. All right, range does not equal to codomain. If you draw the arrow diagram, natural number to natural number, all right, here is 1 2 3, 1 2 3, 2 2 5, all right, and 3 2 7. But 1 and 2 are missing, 1 and 2 are missing, and 4 also missing, 6 also missing, and other numbers are also missing. So it is does not equal. All right, range does not equal to codomain. It means that it is not a onto. It means that opposite is the into. It should be the into function, not a onto function. Okay, thank you for today class.